Alright, in today's tutorial we're just going to do the basic schematic layout in easyEDA tool. And we're going to do a simple circuit design. We're going to go over parts, how to pick a schematic part, how to link a part to it, like getting data from a site, like the part you'll pick or use or whatever. Kind of what the sizes mean, and then just how to lay it out and hook it together. So here we are in easyEDA. We're going to create a new project, and I'm just going to call this simple LED tutorial. I like the name to explain everything. Ooh, space or R to rotate. Okay. So here's your hotkeys. Well, that's good to know. So you can customize your shortcuts. That's cool. I have not used any of these free tools, so this will be fun. Right, I'm gonna leave them as is. I'll go ahead and close that. Alright. So this common library is gonna give you basically everything that is in every circuit. Resistors. This is a potentiometer, so it's just a variable resistor, different, it's a regular capacitor. This is, gosh, what's the word for it? Oh, where it's electrically charged. It's charged on one side, so it's a certain type of, and these are inductors. I can't think of the name right now. Oh well, I'll figure that out later. Pretty common connectors. Common USB type A. Alright, we got some push buttons and a switch. And LEDs. So cool. So we're gonna go ahead. Ooh, they even give you some displays to kind of play around with. Alright. So we're gonna do a couple things. The first thing we're gonna do is I'm gonna just grab a component, and we'll talk about it, and then we're gonna create that same component, because I think it's good to know how to create your own components. It's something that sometimes you'll have to do. A lot of times you can actually get the parts anymore, but there are times where you have to create them. So, oh, you cannot drag and drop. Okay, so they say you have to click it, and then you just click it onto the thing. So I just right click to drop it, and I left clicked to drop it, and I right clicked to cancel. So, see, I canceled what I was doing. Alright. And this is just a standard part. Drawing tools are kind of in my way. Control, middle zoom does not work. Alt, middle. Okay, so middle zoom by itself will zoom into your circuit, the middle mouse wheel button. Whee! Sorry. Alright. So here's our component. And right now it is an R0603 footprint. It looks like you can display the footprint. Okay, so you can display the footprint size if you want. We don't have any supplier because we haven't picked one. So these are pretty common suppliers. We'll get into that in a little bit. Because you can actually add it. And then display name. And then the prefix. So this is pretty common. Resistors are R, capacitors are C, inductors are I. As you place a new resistor, it literally goes up. It's just R1, and then R2, and then R3, and then R4. And it's always just how you place them. So like if the second one's placed, it'll automatically do this. You can change it, but this is pretty much convention. So they're just automatically doing it for you. Let's see. It has a BOM. So BOM is a bill of materials, and it can be converted to a PCB. Alright, so we have a resistor. The next thing is we're gonna add a ground. You always have a ground, and we always have a power. So this is power, this is ground. I'm just kind of throwing these in here. what would also be fun is let's do it's a push button. Let's do a regular switch and an LED. Right. And they said that R is my rotate button. All right. So the resistor is really just so you don't have an influx of power on your resistor line, on your diode. It'll just keep it a little more stable. So we're going to a switch. This is not the right kind of switch. So this is a, I think it looks like a single pole double throw, because it can go two different ways. That's not what we want. See, so they don't have a switch, so we'll build a switch. Yeah, we'll make our own switch, because I know what kind of switch I want to put in there. Alright, so here's our basic components. It's kind of nice. Now we're going to talk about footprint size real quick. See, this one shows you the manufacturer it's linked to. You can change all this. These are just their default library pieces. You can change it to whatever parts you want, so that when you generate your BOM later, your bill of materials later, that you will you'll have the parts that you're gonna order yourself, obviously. You also can, if you send your board to be produced and actually to an assembly line where they assemble it, you'll actually send them that bill of materials and they will purchase the materials and actually assemble the board for you, which is always nice. So you always want to make sure you get right. Sometimes those change because they won't be able to get those items in stock, and you'll have to actually do more research into that. Interesting. Alright, so here's these basic resistor, LED, 1K. Okay, so first thing we're gonna do is we're going to create a new part. So let's see, these are their common. Here's a library. Ooh, look at this. So this library looks like you can actually type in the part number you want and select it, and they already have the piece made with the footprint for you. That's really nice. So you would, and it tells you the price approximately. So you could actually you could go to one of these sites and so right now I'm on DigiKey. Say I just want a regular LED, just a simple diode. What's up here? Packaging. Okay. A lot of these are bulk, so you'll have them on tape reels and stuff. Oh, it's been a while since I looked up. I just want a basic diode. Diode. Single diodes, that's what I wanted. Here we go. I just want a single diode. It's just easier. These are not LED diodes though. Alright. Went too simple. Let's see if they have a single LED. Where's what I found? Oh. Okay. Yeah, let's check out this one. So we don't need drivers because we're only doing one LED. We're doing a very simple design. We just literally want one LED. And I was trying to find something that wasn't surface mounted, so these are all surface mounted. I'm trying to find something that if you were to do it yourself, active. 'Cause, 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 is the most common. No. Created a lot of problems. Max mounting type through hole. All right. Apply all my filters. So I did a through hole, simple design. Here we go. Orange, green, white. Let's go with a common red. So here's your part number. We'll look at this in a new tab. So here's your part number. Stop jumping around. This is if it comes from tape or box. Here's the manufacturer part number. So if I were to take this number, paste it here, looks like it might have added a couple so they don't have it. Oh, it looks like it's all from LSC or EDA. Alright, so they have some parts. Alright, gonna go ahead and exit that. Most of these will have. Alright, ooh, I don't want to put that in. Alright, but on my LED, what I would do is I would go here, I would paste my part number, and you would actually go back over here. Manufacturer is Broadcom Limited. So this is, if you were to build this yourself, you'd be putting all this stuff in anyways. It really likes adding those spaces. And then this should be manufacturer. I can't see with the dots. What is it asking for? I can't open it more. Maybe if I go that way with it. Doesn't tell me what that one is. I'm assuming it's I'm assuming it's this cut tape. That's the model. I'm assuming it's the DigiKey part number. No, and then this footprint, which we haven't checked. That new tab. All right. So what the first thing you need to do is series red wavelengths through hole EDA model. Usually there's the data sheet, and it is not showing me a data sheet. That's interesting. It might be under the models page. All right. It gives you it all. All right. Here's their symbol. Here's their footprint because it's through hole. So this is not a 0603 footprint. It's a through hole footprint. 0603 tends to be, well, I mean, you have through hole that's that size. So let me explain what that is. So it's all metric. When you see that, this is the easiest way to explain it. I like this explanation. The size of the SMD resistor is indicated by the numeric code 0603. So the length is 0.06 inches and the width is 0.03 inches. They also have it for metric. So these are just, it's pretty standard to just put this in the name so that people know what size to purchase when you go. So like I could specifically find a surface mount LED that has a 0603. Actually, here I'll show you. Yeah, because here's our filters. So instead of doing what I did where I changed it to, let's see, where is it, color packaging? Oh, here it is. It's down here. So I changed it through hole, so I'm gonna take that off. Now you gotta come up here. mounting type. Okay, surface mount. And then package. So right here, here's the American size and here's the metric. So it was an 0603, which they do not have that size. So they have an 0606. It's not the same thing. Let's look at the surface mount. This is probably surface mount right angle. Yeah. So it means that the LED is at a right angle. And yeah, they have even less, which makes sense. So they actually don't have that size footprint right now. They have the 0606, not the 0603. So you'd have to alter the footprint or make a new footprint anyways. We're gonna go. Interesting. So they actually, so a lot of companies are doing this now where they have the parts for you. You download it and you import it in directly. So we can, I'll show that, and then I'll also show how to build one. Because one of these things should have a data sheet. And all the information you need is in the data sheet. Sometimes you have to go digging for it. This might be it. Documents, yeah, here we go. Documents. Nope, it goes straight to here. Maybe it gets downloaded with all their models. Anyways, so let's go ahead and download this. Alright, we are using a free software tool, which might not be on here. It might. It is not. Okay, so I'm gonna just put a warning out there. If you pick one of these other versions, it might not import cleanly. So you're gonna have to check the design. You'll actually have to check it. I'm not sure which imports it can do. It most likely is similar to KiCad, though I'm not 100% sure, because not use this. This is one of the other ones. Step file would be for if you're doing the CAD drawing directly, but we want the actual PCB stuff. Let's try KiCad. All right. So we've updated this part. Oh, you can add parameters here. This is if you wanted to add more information. So I've changed all this. The footprint is not going to be an LED 0603. It's going to be a through hole. Which, oh, I gotta remember the convention on that. So everything has a naming convention. This is part of the CID and the CID Plus certification. So that when you make parts, it's recognizable to everybody. I went ahead and I had to look it up. It's been a little while. So this is an LED. Ooh, well, that's how we get into there. There's the footprint. Alright. So here's their footprint. See, it's a surface mount. That's the LED. There's a resistor. Let's see if we look at update. Okay, so that's how you update it. Alright, let's see if double click does anything. Okay, no. Alright, edit symbol. So here's where you'd fix pins as needed. It's an LED, I'm fine with that. not an 0603. So we're gonna have to make a new part. LSC part. Wonder if they don't allow you to make parts. Looks like you can go to these. Not seeing an easy click. Net labels. All that. That's drawing. I wish there was a better spot for these. Kind of just in the way. Okay. Symbol wizard. That might be. That might be a built-in. Ah, this is for if you have SOTs and stuff. Alright. Edit. So, edit. Ooh. New. Here we go. Here's where we'd build a new symbol, a new footprint, and a new 3D model. Let's start with a new symbol. And actually, you should be able to use. Oops, I gotta stop dragging and dropping. Usually, they let you use already created symbols. Ooh, this is placing a component. I don't want to place a component. Let's see. Place a pin. So when you're creating a symbol, you have to place pins. Pins are how you wire up. If you look at all of these, there's a solid and an open dot, or a solid to a line. This is your pin. Pin 1, pin 2, pin 1, pin 2, pin 3. These will match your schematics. Not your schematics, your data sheets. Your data sheets can tell you which pin is which. That's extremely critical on SOTs like this. Sometimes when you start getting up there, they do some interesting things with the pinouts. So you'll want to match what they have. It'll make it easier for laying out your schematic. You can move things around because it doesn't really matter as long as the pins match up with the footprint pins in the correct positions. So on the schematic itself, the pins can be however laid out however you want, but when you're actually looking at matching the pinout to the pins on the footprint, they have to match. Otherwise, you probably fry your circuit. All right. Sorry, I need to drink some water there. All right, so here's pin 1. R is our rotate button. They put their pin like here, and these can be moved. And then they did, these are some, alright, interesting. I would have thought they would have had a symbol that was more similar to, oh, okay, here we go. Diode, so usually, doop-a-doop-a-doop. 3-point. Connect your pin. Diodes always have a line. I'm assuming that's the line tool. I accidentally created extra. So a lot of times you can cut. Put a new one. Alright. So you have to right click to stop it. So you click down once. So you left click to click it down, and then you can move it however you want, and right click to cancel it to finish it off. Alright, so we have pin 1, pin 2. We can, if you really want, we can do the little half arrows. Oops, too far. There's there's probably a cleaner way to do this in this. So if you notice, our grid is snapping. So we can actually change our grid size to half that size to get half that size. Oh, our snap size is still 10. I was like, I'm still snapping to the bigger grid. Okay. So you have to change your snap size. And then we can do a smaller line. We're going to get our polygon again. Doop, doop, doo. I actually probably want to quarter this. Let's do a 2 grid. Snap to 2. Ooh, it doesn't like me going down to 2 on the grid. How about 1? Doesn't like 1 on the grid size either. Interesting. I've never seen that. Okay, well, I might be able to snap to 2.5. Nope, I can snap to 2. Which is kind of off. See, if it was 2.5, I'd be perfectly half. So, if you want it to match, it's just a nice little snap. Ta-da! We just made a component. Yay! Alright, and this is where you would give it its name. And it's an LED. This is where we would do, let's see. That's fine, background color. We haven't made the footprint yet. It's gonna be an LED, so the label will be LED. And then usually, so this is the pre part of the name, it'll have LED in it. We're gonna do DigiKey. So the question mark is when it goes to increment, which actually we're gonna do diode. This is where it'll be resistor 1, resistor 2, resistor 3. It'll be diode 1, diode 2, diode 3. The name, we're gonna do LED. Let them put name in there, and then let's go look at our download file. Download. Extract all. We're gonna extract it here in our downloads. Model. Here's their library file. We do have KitKat, so we can always open and look at it. I was hoping it was going to have the documentation in it. It does not. So what we would do is, we already kind of pasted all this stuff over in here. So I'm just gonna, because I'm creating the part, so we're just gonna go ahead and supplier part number. Sorry. This is the manufacturer part number. I did mix it up because I couldn't read that one. And this is the DigiKey number, because DigiKey is the supplier. I misread that. And then Broadcom Limited is the actual vendor that makes it. They're the manufacturer. We do not have our footprint yet. Name's going to be LED. Let's see. I also don't like when the pin shows both. The pin doesn't need to have one twice. Usually you can turn off the display number or the name. There we go. And so I'm going to turn that off. So it's just cleaner looking. You could turn this red, you can fill it in. So like you can color this. So you're like, oh, this is my red LED. I know this is my red LED because I colored it red. You can do that. Let's see. See, right here. Boom. And you can do solid, fill, red. You can do, yeah, whatever you'd like to do. Make that line black. Kind of like the way the black looks. Alright, LED. And then the naming convention. Here you go. So it is an LED, which right here, LED, and then it's the radial diameter and vertical mounting, and then this is kind of how you would name it. Right here, this will tell you everything you need to know, so we're gonna have to get that information. So let's just, I'm gonna pull up a notepad just to kind of make it a little bit easier. So we won't stick it directly in yet. So it has a radial diameter, so we would do LED radial diameter, and then lead spacing, width, body diameter, and height. So let's go find that information. We have our part over here still, and I'm really surprised. Ooh. I'm not finding the, yeah, that's just going straight to Broadcom. Quantities. And these are the quantities. The bigger amount you buy, the cheaper it will be, but most people, I mean, you're only going to buy like 10. Resistors, diodes, all those kinds of things are usually pretty cheap, at least right now. So usually it would be at the bottom. It would have documents right here, right? And it would have an actual data sheet. And I am not seeing the data sheet, which is really weird to me. The data sheet tells you all the detailed information about the part that you could ever want. Ooh, dark mode. So I find it really interesting that the only thing they have is a link to these, and the only thing you can do is download it, but you can't actually find the data sheet. So we'll do this. I'm going to copy that part number. And yes, this is sometimes data sheet PDF. Oops, not PDG. PDF. Sometimes you'll have to go to their competitor to get the data sheet on the same part. Let's see if they have it. Library loader. This is just so you have all the stuff yourself. Documents. That's a conflicting metal statement. I don't care about that. Nope, that's just sending me back to there. Wow. They really don't want you to have the data sheet on a LED. This is really interesting. Oh. They want you to just download the pieces, which is faster, but I wanted to show, let's see if this one, and make sure that the part number still matches, because sometimes that gets flipped around. There we go. This is what I was expecting to see. Okay, so they actually pulled it from, so they actually had to go directly to Broadcom. Okay. And then they did, usually there's a search engine somewhere. Maybe, maybe not. So most of the time, products. Here we go. Most of the time, whenever there's a, okay. Usually you go to products and then there's usually a search, but man, they have it really gunked up. All right. because usually you just come in, you throw the part number in, and it'll take you straight to the datasheet. We're going to pull the datasheet here. I want the datasheet. Alright, here we go. Yay! Cathode, anode. Alright, we finally have tolerances. Yay! Look at that. Alright. Doo-ba-doo-ba-doo. Wavelengths they're running at. DC forward current. So this is all the data to actually build the circuit. Alright, so we have a cathode, anode, this is your pin 1. Usually your pin 1 is indicated by a square. This is your recommended PCB layout. I'll explain the rest of the parts of the footprint in a second. Okay, so it is, now we're gonna get our numbers for here. Lead spacing is the 254, so it would be the 254, which is common. Width, does it have it there? Width, la 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 la. Go back up to this part. Lead width 254. The diameter is 4.4. So it'd be this. So that's lead spacing. Here, I'm gonna put it down below. So it'd be 254. The width is 4.0. Usually it's diameter 4.4. And then body height. The height is going to be the 5.4. So when it's laying flat on the board, its height is 5.4. This is the tolerance. It's got a plus or minus 0.5 tolerance, which means it can be up to 5.9 in height and down to 4.9 in height. Okay, so I knew something didn't look right on my naming convention. So it's the 254 is the pitch, and then it's width by diameter by height. The X's are pretty standard in most measurements. So this would be our name. Over here, and yes, that is what you would call it. All right. So we are gonna want to save. Ooh. Okay. So in order to save, you're gonna have to sign up with an account. Good to know. See if it's the same thing with this. No, if I use all their components, it allows me to save without signing up. Anyways, so I'm not gonna worry about saving through this video right now. I'm just gonna continue and show you each piece and save it later. All right, so there is our footprint. We've created our footprint. Yay. Okay. Or I'm sorry, we created our component for our schematic, not our footprint. Now we want to make a footprint. Alright, and it actually already has your layers set out for you. Okay, so we're going to go over just kind of basics here. Top layer, obviously top of the board. Bottom layer, bottom of the board. Silk screen is on the top and bottom. Silk screen is the imagery you see around your component that lets you know what that component is at that spot. So it'll say R1 on your silk screen, and you know that's your R1 resistor. It also usually has a base outline around it to show where the component should fit. The paste is for paste and solder for when the component is surface mounted. You're gonna have solder and paste so that it sticks. It sticks better. Board outline is, like it says, you design the width of your board. Then they have mechanical and 3D models so you can see them. So this is pretty standard. If you were to go ahead and add layers, you do it on the board. For just your footprints, this is perfect because your components are only ever going to be on the top or bottom layer. There is embedding, but it's a whole nother process we're not going to get into. So your component's always going to be top or bottom. I recommend always, just when you're building a footprint, do the top layer, do the top silk screen, top paste, and top solder. When you create a pad in most programs, it's going to add the paste and the solder mask for you. It usually already has the calculations in for, you know, approximate tolerances and stuff, so you usually don't have to worry about that. Let's see. So this looks like pad, yeah. So you're gonna create pads, and we're gonna pull up our data sheet. So the diameter of our component is 4.4. So we're gonna drop some pads real quick. We're just gonna place some pads. All right, and then right now I'm on the top layer. I'm gonna go to the top silk screen, and I'm gonna add that diameter of 4.4. So this should have diameter over here. Radius. Okay, we have radius, so half of 4.4 is 2.2. This is millimeters. Let me check what unit this is in. This is in millimeters, so we're good. Okay, so it's 4.4. That's the outside. That's a good silk screen because that's where the component should fit. It just kind of gives you an idea of where your component is on the board. We'll get these other pieces in here. So then we're gonna go to our, the naming convention up. We're gonna come down here to our footprint model. Now, sometimes they have more detailed footprints. With a component like this, it's not really surprising. So the inner diameter is 1.05. And the pitch between the two is 2.54. So these are important. Alright. So we're gonna have our inner hole diameter. Sorry, what was it again? 1.05. So inner diameter. There we go. Okay, inner diameter 1.05. Alright. Then usually there's a tool that we can actually click this component. Alright, here's the X and Y locations. And so right now it should be on X and Y 0, 0. So we're gonna go, 2.54 is the pitch between the two. We're going to divide 2.54 in half, and we're going to go half to the left and half to the right with each pad. So brain no worky worky. 2.54 divided by 2, 1.27. So we're going to move this one over. Why? 0.27. And that was, sorry. And this is actually probably negative, yeah. Negative 1.27. Alright, and then this one should move over 1.27 in the positive. Alright, now we're going to put our circle on our top. We're going to put it at 0, 0 so that it's centered. See how it's perfectly around them? That pad silkscreen side looks great. So usually for sorry, wrong one. For a pin 1, it just makes it an easy marking. A lot of times you'll see them put pin 1 as a square. This just makes it easier to tell which way to place it in. So we're going to do that just out of habit. This is a diode. This is not a thing. And then the footprint. And I gave the part name the footprint name. Out of habit. That's done footprints so many times. Sorry. Here's your footprint name. Alright. Alright, so then we'd go here. And we'd put our footprint. Should be the footprint we just created. Should be able to select our footprint, but it might not let us because we didn't save it. Workspace. Yeah. We'll have to save these, but basically you would just paste the name here and we'll come back to this. Let me actually go ahead and sign up real quick so I can save these parts and show you, and I will be right back. Alright, I'm back. I got signed in, ready to go. Now when I go to select footprint, ooh, oh, wrong one. I should be able to copy that name. Woo! Man, this thing just cuts off really easily. Pin 1, now I should be able to find in my workspace. Workspace, there it goes. Here's my one. See, the pin 1 maps to pin 1, pin 2 maps to pin 2. Make sure we got this correct. I do want to make sure. Where is it? There's almost always another. I'm just not seeing it. Clear. Alright, I'm not seeing it, so I'm gonna double check that my pins are going the correct way. Okay, I just wanted to make sure. My cathode is pin 1, which is negative, anode, positive, pin 2. We can update footprint. If you're ever worried about that, you can also actually take this pin and on name say yes, and we're gonna do boom, negative. I do believe you can drag it out. We can actually say, hey, this is my negative. Go pin 2. I'm gonna put a positive. So if you're ever, I'm gonna move this just so I can grab this positive out. So if you're ever worried or like can't do that, or you know, whatever else, just gonna save. Then you can always add those. I like to add them. I like to see them. Sometimes I even add them on my silk screen. So I'll come here and we'll go to we're on our silk screen there. Okay. And then I'll just add, usually you can just add a line. Arc. Whole track might work. A lot of times you'll just put it just slightly outside because you want to be able to see it. But you just do something like that. Oh, now I know, hey, this is my negative side. Sometimes you'll see it kind of up like that. So here's my negative side. And that just makes it easier to see. Hey, this makes it look screen. A lot of times they'll actually also put the reference designator. So this would match. Yeah, do default. You want it to be clear. So this would match. This would be D question mark. Which actually they should have something that does the reference designator for you. A lot of times they'll do it for you. This is a pretty big font size. 5. Yeah, 1.5 looks a little better. It's not as big. Because a lot of times you have small boards and a lot of parts. Yeah, usually you can link the two, but every program's going to be slightly different. So there's, I do not see a way to link it other than just put D question mark and we'll see if it links when it gets placed. Alright, so there's our footprint, there's our part, and we can actually add the 3D model. We go File, New, 3D Model, and then we're gonna just go ahead and add the file, which actually, let's go back to the original DigiKey file. Okay, and this is where we actually want, let's go to the models. So for just the 3D model, when we download, we want a step file. It's pretty common. Most everything will actually import a step model. Let's just check. It says custom files. So we're gonna find out. Let's see if they have the CAD footprint. Nope. See, okay. So we're gonna go ahead and download a step file. Pull this up. Sorry. I don't need that. I just want the step file. STL is pretty common. These are all IGES and STL. These are all standard mechanical engineering exports. So there's that. We're gonna go here. We're gonna have to export again. Extract all. This one should just be a step file. Now we go here, add file, downloads, should be the one, and ooh, okay, hit all files. Oof, okay, so they can only do an object file. I don't remember. So we're gonna have to figure out which one downloads in the format of object file, because I do not see object on here. So let's go ahead and do an STL. DXF is usually for drawing. Sign Spark. So we're gonna try these. And yes, we're having to download because every program's different. They won't work with certain formats sometimes. So sometimes you're just gonna have to kind of trial and error it. Ah, here we go. Object file. Okay. So here, I'll show you. The STL was object because the other one is labeled IGES. So the STL was the object file. I should have remembered that from other things, but that's okay. Alright, so now when we go over here to add file, I get downloads, it's in my 2 folder, all files, here's an object file. Please select an object file. It is an object file. 3D object file. Details. Let's see, view. View. Lists. No. Details. I wonder why it's not letting me. Properties. Nope, it is an STL file. So it is not a .obj. So we'll actually have to take the ST file and export it as an OBJ file in order to be able to import it into here to be part of our footprint. So I think I'm going to put that into another tutorial video because this video is already getting kind of long. So let's go back to our base circuit. Alright, so we have our new LED part. We should have our own library part in here. Okay, library. My workspace library. Here's my workspace part. And I want to place it. Here you go. Photo. I could have done LED here. I did diode. We can rotate with R. That. Now we're going to go to library. And we're going to go to system. Interesting. So these are different companies. And you can come in here, and I'm actually going to look for a switch. Push button switch. Switches. I don't want a light switch. I don't need a switch that big. Toggle switch. I do want it to be a toggle though. So here we could actually see. Woo! We do not need 6 poles. Or 3 poles. We only need a 1. Well, that's not what we want. Okay, that's a chip that has a bunch of switches on it. We just want a single throw. Dip switch. Yeah, that's just more than we want. There should be something that allows me to do it off the footprint. Flip it. Alright. Huh. Should be a 1. There we go. That's all I want. I'll go ahead and place this part. Just want a single switch. I want to be able to turn it on, and I want to be able to turn it off. Alright. So we're going to go ahead and wire it. which is going to use, these are drawing. Where is, sorry, save out of habit. Oh, here's my wiring tools. I keep having to move this box around. I small screen, so this is wire. You have to use wire to connect properly. Boop. Boop. Do. I like my lines to go straight. Make sure it's connected. Alright, well, it's just going to be connected to ground. Just going to leave it there. So this is your full circuit. VCC. You can, some people will put a VCC, or they'll do like, hey, I'm going to do 3.3 volts. So they'll actually change the name like this. And they usually do this labeling when they're putting tons of different voltages in. Just make it simpler. They have pretty standard, like, look, here's the 5 volt. Here's a standard VCC. I just changed it to 3.3. I can put the positive 3.3 volts going. Here's my normal ground. And then we have what's called net labels. And net labels are if you want to label this net right here, you can be like, oh, input switch. To diode. Like, it's more common when you're trying to keep track of your what's it called? I can't think of the word right now. When you're doing traffic in and traffic out. TX and RX, the transmitting and receiving lines. That's usually when you want to use net labels and stuff. This circuit's so simple, we're not going to worry about it. Alright, the next piece we're going to do here is we're going to do just a simple calculation. We need to get the resistor right. The diode, let's go, I'll show you the diode. Not that one. That's not what I want. I want this one. The diode does, here's the red right here. Alright, so the minimum voltage is 5. So we need to switch to a 5 volt. And the milliwatts, here we go. Current forward is DC forward current is 30 milliamps. So we're actually going to calculate out what our resistor needs to be to make sure that we don't have too much current going across our diode. Because you can fry the diode. So this is, not this. This is one of the simplest things. I'm sorry it's a little blurry. I'll try to zoom in on it and I made it blurry. This is a simple layout of how to calculate things. We're gonna do resistance. We need the resistance. And we know the voltage, which is E. And we know the current we want is 30. So we're going to take 5 volts divided by 30 milliamps. Oof. Let's see. And we should, I think we have to, divided by 30 milliamps. And so 30 milliamps is, I believe, 4 decimal places over. So 1, 2, 3. I think it's 3. Let me check. Milliamps. Chart. Because there'll be a chart with millimeters, milliamps. Let's see. Milli is 1,000. Okay. So it'd be this, and you times by 1,000. So it is 3 decimal places over. So the resistor we would want is a resistor that's about 166. So this would be 166 or 67 ohms. So you'd have to find a part. I doubt you'd find 167. Usually you'll find like maybe 170 or 200. So then our resistor would be 200 ohms resistor, because you don't want to go below that number, because you don't want more current to get to the other side. If the current's a little bit lower, you should be just fine. So this will actually probably end up being 200 ohms. So, and this has to be 5 volts to power that we checked with the data sheet. And that concludes our basic circuit design, including designing your own part, adding a part, editing a part, and wiring your circuit, reading a data sheet, and calculating. And yeah, hopefully I'll get more tutorials out to you guys soon.